Hello, I'm the third owner of this channel. Some time ago, NSA issued a list of so-called safe languages that you're supposed to use instead of those nasty C and C++, and I find it fascinating because it contains Ruby and Python out of all things. It's just like, if you are a high-performance game engine developer in C++, what are you doing programming in such an unsafe language? Think about the children. Consider switching to Ruby. Anyway, at the end of the list you'll find a very special programming language that is surrounded by mystery. It's Ada, the legendary language named after the first ever computer programmer Ada Lovelace and commissioned by US Department of Defense, and has a syntax that looks like Pascal with begins and ends and stuff. Very few people program in this language, but a lot of them are talking about it. What I decided to do is to check out this language on my Twitch channel, twitch.tv/searching, and ended up doing sort of like a 20 days of game development challenge where I set a goal for myself to develop and deliver a game in 20 days in Ada. This was a good opportunity for me to explore the language on something more complex than a hello world and practice my scope management and project delivering skills. Tech YouTubers are famous for their ability to deliver projects, you know. Because one of the biggest problems I've noticed with actually delivering the projects is keeping the scope small. So I thought, what if I give myself like a hard deadline, 20 days, and by the end of those 20 days I must release whatever I've got. That way I'm forced to keep the scope small. The result of this experiment turned out very educational for me, and in today's video I would like to share what I've learned and, most importantly, what I've made. This is Eepers, the game that I made in 20 days in Ada. The best way I can describe it is Dark Souls of Bomberman. The game is turn-based, that means the time moves only when you move. You can be progressing through the level by fighting bosses with your bombs and solving simple mini-puzzles. You are expected to die a lot, but don't get discouraged by that. Take it as an opportunity to learn something new about the game. If the boss seems difficult, that means you're approaching it incorrectly. The game is pretty small. It has only one level and 3 bosses. I had only 20 days to develop this entire thing, come on. The executables for Windows and Linux are available. I'm not some sort of a smelly nerd, so the link to the itch.io page is in the description. It's absolutely free and open source. The link to the GitHub page with the source code is going to be also available in the description. It's under MIT license, so feel free to study it and mod it as long as you're within the MIT license. Special thanks to Type42, who is the author of the soundtrack for the game. To be honest, this particular soundtrack is responsible for like 30% of the vibe of the game. I found them accidentally, right, because I was just like searching for some stuff on Open Game Art, and I just like put ambient. I wanted some sort of like a dark ambient. And I found this track right away, and then I look at some other works of the artists, and it's just like, they're so goddamn underrated. Check out their YouTube, check out of their soundtrack. Like, I'm gonna put all of that in the description as well. It's just like, I was looking for copper and found gold, like for real. Oh, and one more thing. If you find the last boss difficult, this is because you have a skill issue, not because I suck at designing games, okay? But don't worry, there is an easy way to cheese this boss. If you find that way, pat yourself on the back. So yeah, that's basically what you can do in Ada in 2024. So without further ado, let's finally take a look at this mystical language. Let's start with a classic. Let's implement a hello world in it. I'm gonna assume that you already know C and C++ development on a decent level, so you know what is a translation unit, object file, linking, static and dynamic libraries. You are a programmer. I'm gonna assume that you are a programmer. The first thing we need to do, we need to create a file hello.adb. The extension for Ada is called adb, which is rather interesting. Like, isn't it supposed to be Ada? In Ada, there's two main extensions. It's ads and adb. So translation unit, or I think they call them packages, doesn't really matter. So a single sort of like translation unit of Ada consists of two files. The first one is the specification and the second one is the body. Specification is an analog of headers in C and C++, and body contains implementations. So in our case, we're not going to have any sort of like forward declarations for this specific unit or anything like that, so we don't really need ads, we only need adb. The next thing we want to do, we want to create an entry point. So we're going to create a procedure. It's kind of similar to Pascal. If you ever worked with Pascal, you're going to feel at home with Ada. So you have procedures and you have also functions. The difference between procedure and function is that procedure doesn't return a value and function does return a value, right? So the same like in Pascal. Then you have to specify the name of the procedure, right? So, and actually the name has to be the same as the name of the file, but since Ada is case insensitive, you can capitalize it like that. Then you have to say, you're obligated to say is, right? So procedure hello is, for whatever reason, this is just a syntax. And then you put begin and end, which denotes the body of the procedure. Then within the procedure, you have to put a statement that prints hello world into the standard output. And this is a function, actually procedure called put line. And in a double quotes, you say hello world. But this is not going to work because on top of that, you also have to say that I'm linking with ada.text.io. And after that, you will be able to use put line, but by prefixing with this specific package name. To not prefix this specific package name, you need to import all of the names from this package using use. And after that, this is going to work. So how do you even compile this program? You need to have an Ada compiler. What's interesting is that Ada is supported by GCC. In fact, GCC is the main Ada compiler. That Ada compiler is called NUT, and it's integrated with GCC compiler system. So if you use Linux, and I do assume that you use Linux because I don't really know how to use Windows, right? So I'm more of a Linux guy. It's up to you to figure out how to use this entire thing on Windows. I have no idea. So if you're on Linux, these things should be available in your repos. Just search for things like NUT, Ada, and just like install whatever it has. And you may try to just go ahead and do gcc hello adb. And so yeah, it says very interesting thing. It says that -c or -s is required for Ada. -c means that you want to compile a translation unit, and -s means that you want to generate assembly. We don't really want to generate any assembly, we want to just compile the translation unit, and it is going to create an object file. On top of that, it is going to create something called ali file. So, but essentially the only thing we care about is the object file. So we can try to link this object file, creating a hello, and it is not going to work because it needs some sort of Ada runtime, right? As you can see, we're trying to link this entire thing and it cannot find the Ada runtime functions and stuff like that. And this is because you're not supposed to compile Ada programs like that. So what the NUT developers did, they introduced a special command called nutmake. And this command is one of the many commands from the so-called NUT toolbox. And what you're supposed to do, you're supposed to say nutmake the name of the program. Right. And as you can see, it does a bunch of things. All right, so it actually caches some of the stuff, right? So if we remove all of the garbage that it didn't here and all of the garbage that I accidentally created, that happens, and take a look at the full compilation log, you will notice that it does the same thing that we did. It just called gcc with -c, which generated O and some ali file, and then it calls nutbind with that ali file. I have no idea what that ali file is, and only after that you can link this entire final thing and produce an executable that prints a hello world. I've no idea what is bind, but apparently Ada developers added like an entire step into the compilation of a native program, right? So usually what we had in C and C++ is that we had compilation and then linking. So Ada developers, NUT developers were not satisfied with just two steps. They introduced the third one, binding. So you compile your program, you bind your program, and then you only link it. But anyway, so if you're using nutmake, you don't even notice that. There's also this thing called GPR build, which is an advanced build system for Ada, which I personally didn't use because I have an allergy on so-called advanced build systems. Throughout my career, almost 20 years of software development, I worked extensively with such things as CMake, Maven, Gradle, and even a thing which you probably don't know called SBT, which is a build tool for Scala, and I worked commercially with Scala. And the thing about this build tool is that they encourage piling more and more complexity into your project. They make it so goddamn easy that by the time that you notice the price you're paying, it is too late and you can't get rid of those build systems. So as soon as I saw this thing, I realized where it is all going and I didn't even look into that. That doesn't mean that it's not useful. It probably is useful and you probably want to use that. And I'm just saying that I personally don't want to use that and I personally didn't use it for my game. I shipped my entire game without using that at all. I only use not make. Maybe I'm going to use this thing when I feel like it's justified, but for now, I'm gonna put it aside. Another thing that you will probably need is some sort of a mode for Ada, for highlighting the source code in Ada, and you can probably find something relevant for your text editor. In Vim, Ada mode is available out of the box. Probably there's something in Visual Studio Code. There's like literally everything for Visual Studio Code. I don't know for sure, I just don't use Visual Studio Code. For Emacs, if you're using Emacs for whatever freaking reason, maybe you are a weirdo like me, do not use whatever is available in Alpa, because this Ada mode simply does not work. It is a very common and known problem. A lot of people complained about that. When you try to install it, it will simply not work. It will try to compile some Ada programs that will fail with compilation errors. Nobody knows how to fix them. So generally, people suggest to not use Ada mode from Emacs. What we found during those 20 days is a fork of an old Ada mode that actually works, and that's the thing that I'm using right now. Nobody really knows about it, as you can see, but it's a fork of an old version of Ada mode that was distributed with Emacs some time ago, and it actually works. It is beautiful. Thank you so much, T-Kurt Bond. I'm gonna give the link to this repo in the description for anyone who's interested to use this mode in Emacs, if you use Emacs. Alright, so I know how to write a hello world in Ada, I know how to produce an actual executable, but the question is, how do I write and ship an entire freaking game in this language? And the answer is by using shit ton of C and C++ code. If you never heard about Raylib, let me show you something cool. It's a library for developing video games, but it's suitable for developing all sorts of multimedia applications. The games, after all, are ultimate multimedia applications. In the releases on the GitHub page, there are pre-built binaries for the library, so in our case, we probably care about Linux AMD 64. Let's download this thing. So, and if you unpack this library, you will have a bunch of header files, right? So the library is written in C, that's important. And in the lib folder, you have the static and dynamic libraries. I prefer to actually link with Raylib statically. So let's actually try to create a simple hello world with this library, right? So I'm gonna start with just, including stdio, then I'm gonna create the main, the usual thing, right? And then I'm gonna just print a hello world. Nothing particularly special, I just wanna test if I can build this entire thing. So I'm gonna do cco main.c, and I'm gonna run this program right away just to confirm that it in fact prints hello world. So the first thing we have to do, we have to include Raylib itself, raylib.h. And what we can do now, we can just go ahead and initialize a window with a certain size, 800 by 600 for instance. And then we're gonna say hello Raylib. So after that, we have to organize an event loop, right? So any self-respecting GUI application has an event loop. I mean, you're obligated to have an event loop because you're interacting with the user. So there's a special function called window should close, which checks whether the window should be already closed, right? So for instance, the user tried to close the window or pressed escape or something like that. And while the window should not be closed, we keep interacting with the user. How do we keep interacting with the user? We begin drawing something on the screen, then we draw something. For example, we can clear the background, right? So we can clear the background with all sorts of colors. So let's actually clear it with red so we can instantly see that something is happening. And then we can end the drawing. Between begin drawing and end drawing calls, you can actually put all sorts of things. There is a lot of different functions that can draw different primitives, shapes and stuff like that, even 3D. 3D is available in this library. And after that, once you're done with your application, you just close the window. Let's just go ahead and try to build this entire thing. Obviously, it's not going to build because it cannot find the Raylib.h. The Raylib.h is available in the include folder. So what we have to do when we build our application, we have to specify where to search for the header files, right? So via the -i flag. Let's go ahead and try to rebuild it one more time, and this time it builds but it doesn't link, so it cannot find all of these beautiful functions that we tried to call. The thing we have to do now, we have to link with the library libraylib.a, the static one, and it cannot find that, and this is because it is located within the lib folder. So let's fix that as well. Let's tell the compiler where to search for these libraries as well with a -l flag. So let's put / in here, and now it complains with other problems. Now it complains with not being able to find mathematical functions like sqrtf and stuff like that, and it's easy to fix by just linking with the math library, and there we go. We successfully built an application that created a window with a red color. That's it. That's literally it. And you get a native application, pretty self-contained one that doesn't really depend much in terms of dynamic libraries, right? It only depends on libc and libm and stuff like that. So it is a very cool library. I really recommend to check it out. If you plan to make a game, consider using Raylib. Seriously, it's freaking awesome. But why I'm talking about Raylib, it's a C library, right? So aren't we writing in Ada today, right? And Ada is supposed to replace C. And here is the biggest secret in tech. The biggest secret in tech is that majority of the useful code on planet Earth is written in C and C++. And if you're making a language and you want that language to be useful in the long term, you need to link, you need to tap into this unlimited useful code base that is written in C and C++. In fact, if you are programming in Python, majority of the frameworks that you use are basically wrappers around some C and C++ code. They just are. All of the machine learning frameworks, Pygame, the thing that you use for making video games, like all of that is a wrapper around C code. And because of that, this entire idea that we're gonna solve the memory safety of applications with just this magical language that we all simultaneously gonna switch to, it sounds kind of weird to me because we have so much useful code already written in C and C++, and it's enormous amount of effort to rewrite all of that. And nobody's gonna do that. Literally nobody's gonna do that. You start pushing your language like Ada or Rust or anything like that, and then you realize that you can't really do anything useful in it unless you link with C and C++ code. And all of your memory safety features just evaporate. Right, because you're already using this unsafe code, but it's a useful code. It's a lot of useful unsafe code. So because of that, I feel like approaching this problem with memory safety to applications by introducing a new language and forcing everyone to use this language, it's not a particularly productive direction to move in, honestly. A more productive direction, in my opinion, would be trying to do something with C compilers. C and C++ compilers have a lot of different interesting flags that allow you to enable out-of-bounds check, memory sanitization, and all sorts of things like a stack fortification. There's a lot of interesting things you can do with the C and C++ compilers already. I'm not saying that they solve the problem of memory safety, but I'm saying that this could be a more productive direction to move to, because that does not mean that we have to throw away all of that useful code that we rely on. So yeah, so that's basically my take on these memory safe languages. It's pretty cool, but the reality is majority of the code on planet Earth is written in C and C++, and we have to do something with that. As any self-respecting language that is trying to be useful, Ada is capable of interfacing with C. In fact, we can just try to go ahead and link with Raylib in Ada. Let's open our hello world in Ada. super quick, and try to compile it like so. I'm gonna do not make, and it just builds it as it is. And if we take a look at the flags of not make, there should be a thing called largs. Yeah, there we go. So largs. And the thing about largs is that after largs, you provide the arguments that are going to be passed to a linker. Right. So that means one of the things you can do, you can take all of the linker flags that we pass to a C compiler down there and pass them to not via largs like so. Yeah, so it's already built. So it's actually forced to rebuild. And it actually linked with Raylib. It passed all of the flags to the linker, but it doesn't really do anything because we don't call any of the Raylib functions. The way you interface with C in Ada is by using interfaces.c package that comes with the standard library of Ada. So the first thing we have to do with interfaces C, and also we have to import all of the names from this package. And essentially we have to forward declare the functions that we want to use. Specifically, we want to use the function init window from Raylib. We can take a look at the definition of this function. We can just open the header and find the init window function. So here it is. Here is the signature of this entire function. We're going to put it in a comment in here. And it has only 3 arguments, width, height, and the title. So the thing we have to do in here, we have to put the definition of this function between procedure is and begin. This is the place where you're going to do all of the definitions that are going to be available down there between begin and end. So what we want to do, we want to declare a function init window, which is going to accept parameters width. As you can see, you first provide the name of the parameter and then the type. So you use the type int, and the type int is actually imported from the interfaces C. The official integer type of Ada is actually integer, so this is how you declare a variable. This is the variable x, which is an integer. Int is the integer specifically for interfacing with C. So the second parameter that we want to accept height, and it's also an integer. And as you can see, the parameters are separated by semicolon, similar to Pascal. And the parameters with the same type can be grouped together with a comma, like so. Again, like in Pascal. So, and the third thing we have to provide in here, we have to provide the title. So as far as I know, interfaces C exports a special type called char's array, and that's how you pass strings to a C function. In fact, this function does not really return anything, so because of that, it must be a procedure. So since it's a declaration, we apparently don't have to put is after this entire thing, but we have to tell it some extra information about this function. So first of all, we have to say that this function is going to be imported function, right? So import is true. The next thing we have to do, we have to say that the call convention for this function is C. So convention C. And then we can even specify the external name, right? But since this function is already called exactly like the C function, we don't really have to do that. But to be fair, in Ada, you don't really use camel case. In Ada, you use snake case and camel case simultaneously like this. Because of that, maybe it does make sense to provide the external name. Because of the convention of Ada, it's going to be slightly different. Though, in my opinion, it doesn't really matter, but I kind of like to follow the convention of the language that I'm programming. And that's it. So we just declare this function, and we can now try to call this entire function. So let's provide the size of the window, 800 by 600, and then we have to provide the literal that says hello from Ada. But this is not going to compile, right? Because string literals are not char's arrays. We can try to go ahead and just try to compile that. So char's array is undefined, it's called char array, sure. There we go. It actually compiled, surprisingly. So I wonder if it's going to work or not, because by default, Ada literals, they are not null terminated. So right now we're passing a thing that is not null terminated to a C function, and that may blow up. But anyway, so let's try to actually run this entire thing, and it actually successfully run. So as you can see, it started to log Raylib stuff, and then it exited, right? So because we didn't organize an event loop. So to organize an event loop, we need a function window should close, and it doesn't really accept any parameters. The only thing it does, it returns a boolean. So, and we can copy paste this entire thing in here. So it's also imported, convention is C, and the name of the function is window should close. There we go. So now we can organize a loop while not window should close. As you can see, instead of exclamation mark, we have not in here, just like in Pascal. To denote the body of the loop, we have to do loop and loop. For whatever reason, it's not a begin end. And in here, what we have to do, we have to actually begin drawing. And here is an interesting thing. As you can see, if the function or procedure do not accept any parameters, you don't have to put parentheses in here, just like in Pascal. And similarly with begin and end drawing. So let's actually, again, copy paste this entire stuff. So this is going to be begin drawing. Since it doesn't return anything, it's going to be a procedure. Begin Boolean drawing, and then I'm gonna copy paste it again. This is end drawing. So let's try to maybe run this entire thing. So it didn't compile because you have to say return. So not everything just like in Pascal, right? In Pascal, you would use this kind of thing to denote that the function returns something. In Ada, it's returned. So there's a little bit of a discrepancy between Ada and Pascal. So be aware of that, right? So Boolean is undefined. I think it's C Boolean, right? So I don't quite remember. Yeah, it is in fact. And we just created a window with the title Hello from Ada GL Blend Funk. Null termination. Null termination. If I'm not mistaken, to make it null terminated, you have to use a function toC. So, and that thing will take a string literal and basically convert it to char array, also null terminating it automatically. So let's actually give it a try. And there we go. So it says hello from Ada. So yeah, there we go. You can already write games in this thing using Raylib and stuff. So in fact, you can link with any C code in here. And since you can link with any C code, you can do a lot of useful stuff with this language already. And that's literally what I did with my game. So as you can see, I'm basically developing my own bindings, and a lot of people get frustrated when they see me defining bindings myself, because Ada has some sort of bindings generators. But the problem is that I kind of don't trust binding generators. They usually fail, they do things slightly incorrectly, then you have to go and troubleshoot all of that. And I deal with this kind of stuff so many times that I don't even want to go into that in the first place. But maybe bindings generation in Ada is actually perfect. I don't really know. You go try it and tell me. Right, so I'm just doing things my way. Another common criticism that I quite often hear is, why don't you just use the bindings that are already made by somebody else? And the thing is, bindings are not a useful code. It's not particularly useful code. It doesn't solve any problem except interfacing with actually useful code. And by their nature, bindings are just added complexity. And if you're using that added complexity that you don't control, you are in trouble. I like to be in control of this additional dependency that I introduce. But then you may say, isn't it a lot of work defining all of the functions of Raylib? There's a lot of functions in Raylib, like it's like you're wasting time. But here's an interesting thing. Do you really use the entirety of Raylib, or the entirety of any library? In fact, like imagine you're using FreeType, a library for rendering fonts. Are you using 100% of the API of this library? Be honest. You don't. And essentially, why don't you just like define only the functions that you use? That is not that hard, because again, you're probably using like 1% of the API anyway, and you get a thing, very simple thing that you control. Because the problem with somebody else's bindings is that they're not complete, they can be abandoned, and so on and so forth. Right, so, but here you have a thing that does exactly what you want and you control. Thus, you're minimizing the surface area of failure. The more dependencies you can control, the less likely you're gonna have problems in the future. So that's my general approach. You don't really have to do it like that. You don't really have to do it like that. In fact, feel free to use somebody else's bindings. Feel free to use the binding generators. Like, who am I to tell you what to do? What I'm doing in this video is just sharing my approach. If you don't like it, don't do it. Alright, so we established how to make video games in Ada for Linux. But who plays video games on Linux? For video games, there's a special niche operating system that is developed specifically for video games called Windows. The real question is, how do you ship your game on Windows? Luckily, since NUT is part of GCC, it is available in MinGW. So that means you can actually cross-compile your game. And furthermore, in the releases of Raylib, there is a version of Raylib that is specifically compiled for MinGW. So let's download MinGW. We actually need 64-bit version. There we go. And let's unpack it. The thing about MinGW is that it works not only on Windows, it's not just port of GCC to Windows, it also works on Linux, which enables you to cross-compile from Linux to Windows. The utility that you need is actually called x86-64-W64 MinGW32 NUT make Win32. This is a version of Nutmeg from MinGW. It is probably a separate package on your Linux distribution, so you'll have to install it accordingly. You can use this thing as a drop-in replacement for the Nutmeg that you use for building Linux applications. So let's take the command line that we use to build our game and literally replace the Nutmeg. We also have to change the path to the libraries accordingly, so now it has to be Win64 instead of Linux. like so. And let's go ahead and just run this command line and see how it goes. And alright, it complains about missing some things, and these things are Windows specific. If I remember correctly, those things are WinMM and GDI32, right? So these are like Windows standard libraries. And there we go. So this thing just produced a Windows executable. And what's cool is that this Windows executable will work on Wine. I can run this exe from Wine. And I also tested these kind of executables on my actual Windows 8. I still have Windows 8 and they do work. So, and in fact, that's the approach I used to deliver my game on Windows. And it works. It works beautifully. So we know how to write video games on Ada. We know how to build the executables for different operating systems. We can ship it on Linux. We can ship it on Windows. As far as I know, there is an Ada compiler for macOS. Since the source code of the game is open, people have submitted build scripts for macOS and reported that it does in fact work there. But unfortunately, I'm too poor for Apple products, so I can't verify it myself. But let's now talk about the language itself. The language itself is rather interesting. Throughout my 20 days journey, I enjoyed it a lot, but the main problem that I had is documentation. Since not that many people program in that language, not that many people write about that language, and documentation, the state of the documentation is kind of subpar. One of the websites that you will probably stumble upon immediately when you start learning Ada is learnadacore.com. So this is basically the website, the learning website by the developers of Ada. As far as I know, the Ada Core is the company that develops Ada right now. Right, it's an okay place to start, but then later the examples that they provide, I would describe them as not deep enough. At least they were not deep enough for me personally. One of the things I had to do quite a lot is to actually grab the standard library of Ada. So one of the things I did is essentially I would go to user folder in here and I would just find all of the files that end with ADS, because these are Ada signature files. And that will reveal the folder where the standard library of Ada resides. And I would just go there, like so. And here are all of the files in the standard library. And this allows me to just grab some things. For instance, I want to find a function that converts literal to string. And there you go. So I can actually find it in here and read more about it. Since it's an ADB file, this is implementation and stuff like that. So that was actually extremely useful. In fact, this is something that I generally recommend to anyone in any language. Don't just read documentation, also read the source code. For instance, when you're just looking at the documentation for a certain API and you're reading about a certain function, don't be afraid to peek into the implementation of the function to get more insight into how it works. That way you can actually learn more about the library or the language that you're working with. And it's especially important when the documentation for the language or library is lacking. At some point you will have to read the source code, and that's what I generally recommend. The best documentation is the source code because it never gets outdated, because if it gets outdated, it does not compile anymore. People are forced to update it. So yeah. Let's talk about the language itself. The main thing that you see instantly about the language is its syntax. I'm not going to focus on the syntax too much because I don't think it's the most interesting part of Ada, honestly. I think it's the most boring part of Ada, the most uninteresting one. I'd rather focus on the semantics of the language. It has pretty much everything you would expect from a procedural language. There's also a little bit of OOP features from the OOP craze era. I personally didn't use that, some people do use it. The most interesting feature for me personally was Ada's enumerations and how they synergize with Ada's arrays. Let's talk about that. So let's define an array, shall we? The way you define an array in Ada is the same as in Pascal, yet again. You say the name of the array, and then you say the keyword array, and then you have to define the range of the array. So Ada doesn't favor 1-based indexing or 0-based indexing. It's up to you to decide, right? So you can define from 1 to 100, right? So in that case, it's going to be 1-based indexing. And we're going to say that the elements of the array are going to be integers. Let's initialize this array. Let's iterate, starting from 1 to 100, the entire range of the array. And then we have to assign a value to each individual element. So let's actually use the double of the index as the value. There we go, we initialize the array. So after that, let's go ahead and print each individual element of the array. Ada has a second way of iterating arrays, which is similar to for each. So essentially you can say for x in axis, and that will iterate each element of axis by a reference. X is a reference to each individual element, loop and loop. And then we can go ahead and print the x. So to convert x into a string, you have to use single quote image. Don't ask me why this is just Ada being Ada. If you want to convert some sort of a type to a string, you have to do the image. So a string that represents the type is called image for whatever reason. Let's go ahead and try to print this entire thing. And something went wrong because you're supposed to use off instead of in to do a for each, of course. And there we go. So we actually initialized and printed the array. Pretty cool. So if we have to change the capacity of the array, we have to change it in two places, in here in the definition and here in the loop. So there is a way to actually fix that. So you can take access and say that you're iterating the range of that array. So essentially this part of the array definition is called range, and you can take the name of the variable and you can take its range, and that will work. So you only have to modify the capacity of the array in one place. In fact, you can take the range and turn it into its own separate type. Right, so define a new type in Ada, you have to use a keyword type. Then let's call this type something like access index, and then we're going to say that this particular type is a range from 100 to 200. And that enables us to use literally this name instead of the range, and that will actually work, almost. Yeah, and this one is very interesting because access index creates a completely separate type, which is not compatible with the standard integer. So here, I can't just take index and just like assign it to here because the element is supposed to be integer. So I suppose one of the things I can do in here, I can forcefully cast an index to an integer, and that will actually work. So essentially, if you have a variable which is called I, and it's an integer, and it's something like 69, you won't be able to index access with that specific variable at all, because it's not compatible with the expected type of the index. That's the power of Ada. So why is that so powerful? There is a very common trick of using indices instead of pointers in languages like C, C++, Rust, and generally in all of the languages. You can say that index in an array is kind of similar to a pointer. It's a relative pointer, a pointer relative to the beginning of the array. And in fact, indices are such a powerful technique that they allow you to circumvent borrow checker in Rust. And Rust developers will go completely ballistic if you tell them something like that. Indices do allow you to bypass borrow checker, because if you treat index as sort of like a reference to a particular element in an array, you can have multiple indices to a same element in the array simultaneously, by which you're going to be modifying things, thus bringing back the problems that the borrow checker is supposed to solve. And it's a very common way to, again, circumvent borrow checker, and it's a very easy way to implement, for example, a circular linked list in Rust. But the problem with just indices instead of pointers generally, even in C and C++, is that pointers at least have a type associated with them that they're referring to. When you are starting to use indices instead of pointers, you kind of losing information about which array that index is indexing. Ada is actually fixing that problem. You can take the range of an array and turn it into its own separate type and tell Ada, use that type for indexing that specific array. So now the index actually restores the information about which array it can index, like so, right? And it not only becomes stronger typed, but it also becomes self-documented. If I look at I and I look at its type, I know, oh, okay, that thing indexed that specific array. They are now connected somehow. On the other hand, if it was just an integer, I would never know if I is somehow connected to access unless there was some sort of a comment, some sort of a note telling me that explicitly. But now I don't have to have a comment for that. I can see that in the code directly. Very much convenient. And by the way, this is what I constantly use throughout my game. If we open the source code and take a look at the game state, alright, so game state is a huge structure, right? So the structures in Ada are called records. So you define type, game state is record, and you can have fields of the record in here. So in here, I have an array of entities. I call it Eepers. If we take a look at the definition of Eepers array, it is a type which is an array which is indexed by Eeper index. And the range is from 1 to 15 because the game is very much simple. I just don't expect to have that many entities in the game. So I basically have a fixed array of entities. And what's cool is that now I use this Eeper index instead of a pointer to a particular entity throughout the code base. So let's actually take a look at that. Right, for instance, I have a function that answers the question Eeper can stand here. So, and in here I accept the state of the game, the position within the game, within the grid of the game, and then the index of the Eeper. And then I look up that specific Eeper and I take its size and I just check if this thing can stand in here. It becomes a replacement for a pointer throughout the entire game. Furthermore, you don't have to use ranges as an indices for the arrays. You can also use enumerations, right? So for example, let's define enumeration which is called, I don't know, direction, right? So, and the kind of directions you can have in a grid-based game is usually left, right, up, and down. And there we go, so you've got a direction. And now you can define an array which associates a direction with a specific vector. Let's actually call it something like direction vectors, right? And it's going to be an array indexed by direction of, for example, vector 2. And vector 2, let's say, is going to be something like a record. So records are structures, and so essentially it's going to have two fields x and y, which are going to be floats. And then you can even pre-initialize this sort of like a table, saying that, for instance, the direction right is associated with moving to, let's say, 1, 0, right? All of that has to be floats. By the way, this is a very cool feature of Ada. Again, if you have a record, you can have record literals. So essentially you put parentheses, and within parentheses you sequentially put the values of each individual field in here. But if you want to be specific, you can actually put a name in here like so. There we go. And you can basically associate each individual direction with some sort of a vector, right? So moving to the left decreases x, moving up does not change x at all, but it decreases y, moving down increases y. And there we go. Now you have a table of different directions, which is rather convenient, and it only can be indexed by that enumeration and nothing else. It cannot be indexed by integer. You can forcefully convert an integer to a direction, but accidentally you can't just use a wrong type for an index of that specific array. And since this array doesn't ever change, you can also make it constant. It will prevent it from modifying it and maybe enable some optimizations, I don't know. So, and this is exactly what I was talking about when I said that arrays and enumerations synergize in Ada. In fact, I think I already have the type direction defined in my... Yeah, there we go. So it is defined in my game, and I have precisely this kind of table. So let's actually see where else I use this kind of stuff. Right, so here I'm iterating each individual direction. So let me take a look at the context of where it is defined. Recompute. Oh yeah, so here is the pathfinding. Right, so I'm using BFS to make the enemy's path find the player. And to maintain the wave at each individual iteration, I have to look around the cell. And because of that, I'm just iterating each individual direction. Right, and for each direction, I get the direction vector and I compute the new position based on the old position, and then check whether I have to go there or not. So this is one way to use this kind of feature and stuff like that. And I use this kind of stuff throughout the game, and it really helps me to build up this domain-specific dictionary of the problem I'm solving. It is really freaking cool. It might not be a super impressive feature for people who like sophisticated languages like C++ and Rust and stuff like that. They like to bathe in these complicated abstractions and everything. But as a person who really values simplicity, as the person who really admires simplicity, I really like this simple feature that allows me to describe so many things without even writing a single comment, because I can bake a lot of information, I can bake a lot of story into these enumerations, into these ranges, into those indices. I can really tell a story by writing a code, and this is the coolest feature of Ada in my opinion. And it might not be impressive for a lot of people, but I really enjoyed it, and I wish more languages really married together arrays and indices. And to be fair, this video doesn't do the justice for Ada, because Ada has a lot of interesting features that I just cannot cover on this video because it's already too long. So for example, I didn't even take a look at such thing as Spark, which is a formal verification tool for Ada. So essentially it's some sort of like a small subset of Ada with additional thing that allow you to really prove the correctness of your application, which is very useful for application that really need like an extra security. I also didn't look at the concurrency in Ada, so the Ada has a very interesting take on concurrency that I tried on one of my streams and I kind of enjoyed it. Ada has a lot of interesting stuff and I wish that a lot of people explored this language so we had more information about it. So yeah, anyway. Should you bother with learning Ada? If you're only starting programming and you're trying to get into this industry because there's a lot of money in here, right, and you're looking for some language that is easy to learn and that will score you a job at FAANG, don't bother with this language. This language is definitely not for you. Who this language for? I think I would recommend this language for people who are passionate about programming. They are passionate not only about programming but also software engineering. And by software engineering I mean not just writing code, but also trying to produce an executable that has certain kinds of parameters, certain kind of performance, certain kind of memory footprint, not just writing code, but actually engineering a piece of software. I would recommend this language for these kind of people. And also, if you are passionate about programming languages in general, this language has quite a few interesting ideas that you may enjoy. And will this language replace C and C++? I don't really know. And I'm not sure if I even care. I just like programming.